For the second group of circle problems, we're going to look on page 186 at problem number 37. It says the center is at the origin and it contains the point -2, 3. So it's helpful to put that on a graph to see what we're talking about. The center's at the origin and the circle contains the point -2, 3. So what that tells us is that the circle goes something like this. Well, imagine that's a better circle. So that this is the radius. So if I find the length of that line, then I'll know the radius of the circle. Well, I can find the length of the line because the 2 points that I'm dealing with are 0, 0 and -2, +3, and I can find the length of that line using the distance formula. So I'm just going to substitute -2 minus 0 squared plus 3 minus 0 squared and clean that up doing the math. So that becomes -2 squared plus 3 squared, or 4 plus 9, which is the square root of 13. So the length between these 2 points is the square root of 13. So that represents my radius. And I already knew that the center was 0, 0. So this is my radius. It told me that the center was 0, 0. So I'm just going to substitute that information into the general form for the equation of a circle. So x minus the x-coordinate squared plus y minus the y-coordinate squared equals the radius squared. Well, x minus 0 is just x, and y minus 0 is just y. When you square a radical, it just removes the radical and you get the radicand as the answer. So that becomes the answer for number 37. It asks me to find the equation of the circle, and there's my answer. The next problem is number 39, and that problem says we have a center at 2, 3, and it's tangent to the x-axis. Well, what that means is, if it's tangent to the x-axis, it barely touches the x-axis as it comes down around this way. That's not a good picture. Around, as it barely touches the x-axis here. Imagine that that looks like a circle. So the distance from this point to here, that's my radius, because that just does touch the x-axis. Well, I can count that that's 1, 2, 3. So I know that the center's 2, 3, and the radius is 3. So if the center is the point 2, 3, and the radius is 3, my equation becomes x minus 2 squared plus y minus 3 squared equals 3 squared. X minus the x-coordinate squared plus y minus the y-coordinate squared equals the radius squared. So I'm just going to actually square the 3 and get 9, and there's my answer. Now, the last problem in this group is number 41, and what number 41 tells me is that I have endpoints of the diameter at 1, 4 and at -3, 2. That's the diameter. Well, the diameter goes all the way across the circle, so the center is in the middle of it, and the distance from here to here would be a radius, or I could use this distance. Well, to find the center, that's the midpoint. So I had the points 1, 4 and -3, 2. And I learned earlier that to find the midpoint, I add the x-coordinates and divide by 2, and I add the y-coordinates and divide by 2. And that becomes the midpoint. So 1 plus -3 is -2, and 4 plus 2 is 6. -2 divided by 2 is -1, and 6 divided by 2 is 3. So now I know that my midpoint is the point -1, +3, right there. Now, to find the radius, I have some choices. I could find the length from here to here and take half of it. I could take the distance from here to here, or the distance from here to here. Any one of those three should give me the same answer. So I'm going to choose to do this one. I'm going to go from -3, +2 to my center, which is -1, 3. And I'm going to find the length of that line using the distance formula. So x minus x squared minus a -3 became a +3 plus y minus y squared. So that becomes 2 squared plus, that's 1 squared, or 4 plus 1, which is 5. So I now know my center from right here, and I know my radius from right here. So I can write the equation x minus the x-coordinate. Again, minus a -1 up here is how I got a +1, because it's x minus the x-coordinate plus y minus the y-coordinate equals the radius squared. So x plus 1 squared plus y minus 3 squared, and the square root of 5 squared is just 5. When you square a radical, you just get that number itself. Up to this point, every equation that we've been asked to write said write it in standard form. The next group of problems we're going to look at says write it in general form. And to do that, you start with it in standard, then you do the multiplication, you subtract whatever's on the right-hand side to make it equal 0, and then you line it up in this order: the x squared, the y squared, the x, the y, the constant, and it equals 0. And that's what we call general form. That's on your handout about equations of circles. So to practice that part, we're going to back up on that same page to problem number 15. And it tells us there that the radius is 2 and the center is 0, 2. So we've got a radius of 2 and a center of 0, 2. So we start by writing that in the standard form. So x minus the x-coordinate plus y minus the y-coordinate squared equals the radius squared. So x minus 0 is just x, and 2 squared is 4. Now what I have to do is to expand this binomial. And to do that, I go over here to the side, and to square y minus 2, I multiply it by itself. Using the distributive property, I get y squared minus 2y minus 2y plus 4, or y squared minus 4y plus 4. Y times y, y times -2. -2 times y, -2 times -2. Or you can call it full if you want to do that. So when I expand this binomial, this is what I get. So I'm going to replace that with y squared minus 4y plus 4. Now, as my handout said, to be in general form, this term needs to be a 0. So that means I need to subtract 4 from both sides of the equation. And when I do that, it not only makes this a 0, it makes this a 0. So this is my answer in general form. This was my answer in standard form right here. And this is my answer in general form. So general just multiplies out the binomials. All right, so next we're going to look at number 17. Same page, 186. It tells me that the radius is 5 and the point is 4, -3. So I start with writing the standard form, x minus the x-coordinate squared plus y minus the y-coordinate squared. Again, minus a negative is how that became a plus, equals the radius squared. So I go off to the side and I multiply x minus 4 times x minus 4. When I do that, I get x squared minus 8x plus 16. And I go off to the side and multiply y plus 3 times y plus 3. And I get y squared plus 6y plus 9. And I'm going to go ahead and square the 5 and get 25. All right, so now my handout said, remember the order, I need x squared, x, y number. So I'm going to write this x squared coordinate first. Then I'm going to write the y squared term. Then I'm going to write the x term. Then the y term. And let's see what's going on. I've got 16 here and 9 here, which makes 25. This side needs to be 0. That's the 25 I just copied right there. Well, again, when I subtract 25, this doesn't always happen, but it's happened twice now, that when I subtract this to make that a 0, it also makes the constant term 0. So I just have x squared plus y squared minus 8x plus 6y equals 0. And that would be the answer for number 17. For the last problem in this group, we're going to look at problem number 19, where we're told that the radius is 4 and the center is -2, +1. So x minus a -2 plus y minus 1 equals the radius squared. So again, you go off to the side and you multiply x plus 2 times x plus 2. And I don't need that parenthesis. You get x squared plus 4x plus 4. And then you multiply y minus 1 times y minus 1, just using the distributive property or FOIL. And you get y squared minus 2y plus 1. And I'm going to square that 4 and get 16. So now to line things up, I'm going to copy my x squared term, then my y squared term, then my x, then my y, and for the constant, I have a 4 here and a 1 here. So that's 5. To make this side 0, I need to subtract 16. So I get x squared plus y squared plus 4x minus 2y, and 5 minus 16 is a -11 equals 0. So again, this is the answer in standard form, and this is the answer in general form. And this particular set of problems asks for it both ways. Maybe we should do one more because it has a fraction in it. Number 21, the radius is 1/2 and the center is 1/2, 0. So x minus the x-coordinate plus y minus the y-coordinate equals the radius squared. Whoops, can't see that. All right, when you go off to the side, I'm going to actually show you this one. When you multiply x minus 1/2 times x minus 1/2, x times x is x squared. X times minus 1/2 is minus 1/2 x. Minus 1/2 times x is minus 1/2 x. And minus 1/2 times minus 1/2 is a positive 1/4. Well, a negative 1/2 and a negative 1/2 makes a negative 1. So that becomes x squared minus 1x plus the 1/4. The 1/2 and the 1/2 is where we get the 1. So I'm going to come back over here and replace this with x squared minus x plus 1/4. The y minus 0 squared is going to just be y squared, because y minus 0 is just y. And the 1/2 squared is going to be 1/4. So I'm going to copy my x squared, copy my y squared, copy my x. There is no y term, so I don't have to worry about that part. Then I have a positive 1/4 on this side and equals 1/4. So again, to make it general, I got to subtract the 1/4 to make this one side 0. And I end up with x squared plus y squared minus x. That zeroes out, and so does that. So there's my answer in general form. Now you're ready to go to my math lab and do the problems on the circles.